Welcome. This is the Chapter P, the prerequisite chapter for Precalculus. Summary and review for our test that is upcoming. So to get this started, I did share through the classroom the practice test. But before we get to that, I want to just go over some of the things that you should know how to do from this chapter. And it's pretty much put together here in this summary of the basic formulas that you should know. Let's start at the top. The definition of absolute value, right? The absolute value is the distance from the origin. And when we calculate it, we know that we basically just make something positive, and we can see that if x is greater than 0, then the absolute value of x is just whatever's inside the absolute value signs. However, if x is less than 0, then it is the opposite of whatever's inside the absolute value sign. Okay. To find distance between 2 points, we just subtract those 2 points and then take their absolute value, right? It tells us how far 2 points are away from each other on a number line. Some properties that you should know. The commutative property basically means that of addition and multiplication means that we can switch the order in which we do those operations and we're going to get the same thing. The associative property just means that we can change the things that we do first. We can change grouping symbols with addition and multiplication. Distributive property just means that we take A and multiply by B and then by C. That's the distributive property of multiplication over addition. Works for subtraction too. Our identities, right? Our two basic identities. Our additive identities is the thing you add to something to keep it the same. So that would be 0 would be our additive identity. And our multiplicative identity, the thing you multiply something by and it stays the same, is 1. For inverses, the definition of an inverse is the thing that you add or multiply to get back to the identity. So in addition, we want to get back to 0. For multiplication, we want to get back to 1. So opposites, a plus negative a, opposites add together to give you 0. A times 1 over a, reciprocals multiply together to give you 1. So all those are just basic properties. We really won't have too much that you have to memorize for this test. What we are going to do is we are going to use these things, okay? So this is where we really come into the stuff that you're going to have to be able to use, okay? And those are all the properties of exponents, okay? So the first property is if we have a negative exponent, it moves to the bottom of a fraction. Anything to the 0 power is 1. If we have the same base multiplied together, we can add the exponents. Power to a power, we multiply the exponents together. Same base with division, we can subtract the exponents or cancel. Product to a power means we sort of distribute this exponent, right? Everything inside the product gets raised to the power. Everything inside the quotient gets raised to that power as well. One thing I'll add to this is that a over b to a negative n power, if I want to make that n positive, it can switch to b over a to the positive n power. Might make the problem a little bit easier to have a quotient to a positive power instead of a negative power. Okay. For product and quotient rules, as long as the index is the same, right, we can split up radicals, and we can split up products and quotients. Fractional exponents, rational exponents, all my properties of exponents are still going to be the same, except now we're going to be dealing with a root, okay? So 1 over a to the 1 over n power is the same thing as the nth root of a. Okay. And if it's negative, we move to the bottom of a fraction, and it becomes a radical in the denominator, which we would, of course, have to rationalize later. If we have a more complicated fraction, m over n, the numerator is the exponent, the denominator is the root, as you can see right here or right here. If it's negative, it goes to the bottom of a fraction. Okay. a couple of special products for multiplying binomials together. We multiply two conjugates. You should know that a times b times a minus b gives you a squared minus b squared. A plus b squared, right? A squared plus 2ab plus b squared. If you really wanted to, right, you can take that and make a plus b times a plus b and multiply it out. But if you can remember this special product for the positive and the negative, you can get there a lot quicker. These two are good to know. Probably won't see them too much here, but definitely good to know. The factoring formulas are most of the special products except backwards, except this is cubing a binomial. This is two separate cubes added together, the sum of cubes, the difference of cubes. Okay, so if we have the difference of two perfect squares, that factors, just like the product up top. Our perfect square trinomials factor into a plus b squared or a minus b squared. And we can factor the two perfect cubes by remembering our acronym SOAP. Same sign, opposite sign, always positive. Okay, and then this part you actually just have to remember, right? A minus b, a squared, ab, b squared. AB, not 2ab. If it was 2ab, this would factor more. It doesn't, and it can't. Okay. And to finish up our equations here is absolute value equations. We didn't really talk too much about inequalities, but what you should know is that in all these, c has to be greater than 0. Why? Because absolute value is distance, and it must be positive. Therefore, if we have an absolute value equal to a number that is not greater than 0, you get no solution. However, if we do have an absolute value equal to a positive number, we consider the positive case of the absolute value. If inside the absolute value is positive, it would be equal to c. If inside the absolute value is negative, the absolute value would make it positive, so therefore u can be equal to negative c as well. With a less than inequality, less than and less than inequality, we have a conjunction, and just like an and inequality. And with a great or than, great or, we have a disjunction, an or inequality. Finally, the quadratic formula. All quadratic equations, even the ones that factor, even the ones that you should use a different technique for, anything with an x squared can be solved by negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So those are all our formulas. Let's jump into these questions. Okay? So the first 10 or so, the instructions there are to simplify each expression completely, or perform the indicated operations like addition and subtraction. And we are going to assume all values represent positive numbers. That means that if we have a radical, we don't need any absolute value signs. And if something's in the denominator, we should state any restrictions on the variables. Okay, so first question was kind of like a warm-up. Okay, so here we are going to simplify by getting rid of the parentheses, and we're just going to distribute the 5. So we're going to start with 10x squared minus 30x. We are going to distribute this negative sign, minus 4x squared plus 3x. Okay. Like terms can go together. So we have 6x squared minus 27x. Now, that is simplified. Yes, we could factor something out. We could factor a 3x out. But now we're putting back parentheses, right? When you want to be simplified, we'll get more into the rules for fractional or for exponential expressions. But part of being simplified is we want to get rid of all the fractions. We have gotten rid of all the fractions. That's it. We're done. And that is the answer. Okay, so for number 2, we're going to simplify this expression. Okay, first, I need to know kind of what it means. That symbol right there means intersection. This right here means natural numbers. So recall that the natural numbers are 1, 2, 3, 4, 5, the counting numbers. Okay. Not an intersection means everything that these two sets, this set and this set, have in common. Well, natural numbers are not letters. Natural numbers are not negative. Whole number is 0, but natural numbers is not 0. So the answer for this is 1, 2, and 3 with my set notation. That is the intersection of this set and this set. All right, moving on to the next one. Okay, so when I first look at this problem, okay, there's a couple things I don't like. I don't like this, and I don't like that there's more than one x is more than one y. Let's handle this negative exponent on the outside first. And what I can do is I can change that to a positive exponent by keeping everything exactly the same and just flipping the numerator and the denominator. So in the numerator now is going to be 10, x to the 5 over 3, y to the negative 2, over negative 30, x to the 3 over 2, y squared. Okay. To be simplified, I have to simplify any numbers. I have to make myself one of every letter, and then make sure there's no negative exponents and no fractional exponents in the denominator. So here we have a 10 over 30, which would be 1 over negative 3. Okay, I'm not going to put the 1 up there because I think there's going to be other things up there. Let's see. We have a 5 over 3 at the top. We have a 3 over 2 at the bottom. So in order to simplify these, I'm going to need to subtract. So we take 5 over 3 minus 3 over 2, and I get a positive 1 over 6. If I had gotten a negative number, I would have put it in the bottom of a fraction, and I would make it positive then. Okay. With this negative exponent right here, it goes down to the bottom and combines with this y. Now, I must square everything. So, power to a power, we multiply exponents together, which gives me x to the 1/3, right, 2 over 6. Negative 3 squared is a positive 9, and y raises to the 8th power. Let's see if I'm done. There's no more numbers to simplify. My variables are all different. There are no negative exponents, and there is no fractional exponents in the denominator. Okay. If there was, I would rationalize it. Next. Well, this problem looks complicated, right? If you take it one step at a time and nice and slowly, you should be able to handle it pretty easily. There's one thing here that jumps out at me as a good place to start, and that's something raised to the 0 power. Anything raised to the 0 power is always 1, so this just goes away because 1 times all of this is just all this. All right, so let's start then by product to a power. Let's raise all these to the negative 2 power. So I'm basically going to distribute the exponent. So that turns into 2 to the positive 2 power. Negative 1 times negative 2. X to the positive 6 power. 3 times 2. Y to the negative 2 power times 2 to the negative 2 power. X to the negative 6 power. Y to the negative 6 power. Over 2 to the positive 2 power. X to the negative 4. Y to the negative 6. All right, now I look for stuff to do. Opposites on the top can cancel each other out, like x to the 6th power, x to the negative 6th power. When I add those exponents together, I get 0. So those two go away. Anything that's exactly the same on the top and exactly the same on the bottom cancel, like y to the negative 6 and y to the negative 6, like 2 squared and 2 squared. Then this 2 to the negative 2 power can move to the bottom, so it becomes positive 2, and 2 to the positive 2 is 4. Okay, well, that gets rid of this one, right? So what's left? I got a y to the negative 2 and I got an x to the 4, negative 4. Move the x up top, turns positive. Move the y down and it turns negative. And that's it, because there's one of every letter. There's no other numbers I can simplify. There's no negative exponents. There's no fractional exponents in the denominator. That is simplified. Okay? And with both this one and this one, I could say that y is not equal to 0. So that way I know that that would make this function undefined. That is less important in this example than in the one after this. Okay? This question, 2 radicals, both square roots. Why not just put them together so I can simplify this? So 500 x to the 3rd over 10x to the negative 1. Well, now it's a fraction that I can simplify. 500 divided by 10 is 50. This negative exponent goes up to the top and gives me x to the 4th. 50 x to the 4th, the square root of 50. I can break that up into the square root of 25 times 2. And why did I do that? Because 25 is a perfect square. So this gives me 5. The square root of x to the 4th is x squared. And the 2 got left behind. Right? So if I'm taking the square root of x to the 4th with an exponent, we divide it by the index. So it becomes 4 divided by 2 to give me 2. For this one, these are cube roots. These are not the same. So I can't add these together the way they are. But if I made them the same, I could add them together. So let's simplify these as much as possible. Okay, so in order to simplify 24, I need to think of the largest perfect cube that goes into 24. And it is 8. If you're not sure, we could break this up, 8 times 3, into a factor tree, 4 times 2, 2 times 2, and groups of 3s are what we can take out of the perfect cube. Okay? So this basically turns into 3 times the cube root of 8 times 3x to the 6, which then the cube root of 8 is 2, which comes out here and multiplies with this 3. The cube root of x to the 6 is x squared, the 6 divided by the 3, and we're left over with the cube root of 3. Plus, let's do the same thing for 81. So the cube root of, well, 81, let's see, what's a perfect cube that goes into 81? How about 27? 3 times 3 times 3 times another 3 is 81. Okay? The 27 can come out and turn into a 3. The x to the 6 comes out and turns into x squared. And we're left with the cube root of 3 behind. Now, these two are exactly the same. These two are like terms. So now I can put these together, and it gives me 9x squared, the cube root of 3. And the directions in the beginning said assume all variables represent positive numbers, so I don't need absolute value. I don't need to worry about absolute value. But in any case, this is an odd root. I didn't need it anyway. Up here, I used the quotient rule, so I didn't need it anyway. All right. let's get to a rational expression. Here we are going to list the restrictions on the variable, right, for the rational expressions. Factor, cancel, figure out what you're not allowed to have in the denominator. Okay? Factors of 18 that subtract and give you 7. Whoops. Factors of 18 that subtract and give you 7. So we have x plus 9, x minus 2. X times x is x squared. 9x minus 2x, inside outside, is 7. 9 times 2 is negative 18. Good. Factors of 2 that add to 3. That's x minus 2 and x minus 1. Right? Negative 2 and negative 1 is a positive 2. Negative 2 plus negative 1 is a negative 3. Any factors that are exactly the same cancel. So my answer is x plus 9 over x minus 1, comma, x is not allowed to equal anything in this problem that made the denominator equal to 0. Well, if I had a 1 in there, that would make that piece equal to 0. If I had a 2 in there, that would make that piece equal to 0. So x is not allowed to be 1 or 2. Okay, so just factor and just cancel. For number 8, looks complicated, really not that bad. When we have a complex fraction, the best idea is to multiply everything, every term, by the common denominator of every term. Well, this is x squared, x third, boom, boom, boom. The common denominator would be x to the 6th power. When I multiply these, x to the 6th over x turns into x to the 5th. These, x to the 4th, and these, x to the 3rd, over, same thing on the bottom, x to the 6th over x to the 4th is x squared plus x plus 1. Okay. Well, look here. We can factor out an x to the 3rd. And that leaves me with x squared plus x plus 1 over x squared plus x plus 1. If the whole denominator is the same as a factor, it can cancel out, which makes my answer x to the 3rd. But x cannot be equal to something that made the denominator equal to 0 in this problem at any point. Well, the factors of 1 that add to 1, there aren't any real numbers there, but if I plug 0 into any of those, it would have made my denominator equal to 0, and therefore we have to exclude it. All right, now we get into some fun ones. Parentheses first, multiplication first, then we'll find a common denominator to subtract. Okay, but let's factor and see if anything can cancel. 2x plus 3, nothing to do there. X plus 1, nothing to do there. Times, let's factor this expression up top. Factors of 5 that subtract and give me 4. Well, that's going to be x plus 5, x minus 1. The factors, okay, so recall what we can do with this. We could do the guess and check method, right? We can make 2 sets of parentheses and try to figure out how it factors with the number in the front. Or we can use the AC method, multiply the 2 and the negative 3 together and find the factors of negative 6 that add to 1, and then factor by grouping. Okay? We should be able to do this just by the guess and check method, because I know that has to be a 2x, that has to be an x. And my only choice is a 1 and a 3, because those are the only two factors, those are the only things that multiply together to give you a 3. So I don't want to put the 3 here, because then that would give me a 6 on the outside pair. And I don't want a 6, I want to have it just be a 1. So I want the 3 there, I want the 1 there, and I want this middle one to be positive, which means I want the positive there, the negative there. So look what happens. Inside pair, 3x. Outside pair, minus 2x, gives me x. Minus 2 over x plus 2, which we'll get to in a second. Look at that. Nice. And unfortunately, the x plus 1 doesn't cancel with anything. Let's double check that. -5, +5 minus 1. Okay. So, oh, wait, -1. Cancel there, cancel there. Okay, I knew I was missing something. All right, so now we have x plus 5 over x plus 1 minus 2 over x plus 2. In order to subtract two fractions, they must have a common denominator. So the common denominator here, is going to be x plus 1 times x minus 2. X plus 2. Okay, so that means I need to multiply this expression by the piece of the common denominator that is missing. So I take x plus 5 and I multiply it by x plus 2, because I already had an x plus 1, minus 2 times x plus 1, because I already had the x plus 2. My denominator, x plus 1, x minus x plus 2. FOIL and combine like terms. So we have x squared, 2x, 5x is 7x plus 10 minus 2x minus 2, which gives me x squared, the 7x minus 2x, so that's plus 5x plus 8 over x plus 1, x plus 2. Now, are there factors of ugly 8? Are there factors of 8 that add to 5? Well, the factors of 8 are 1 and 8, which adds to 9, 2 and 4, which adds to 6. That's it. So, no, which means we're done. Except, we need to say that x cannot be equal to anything that made the denominator equal to 0 ever. That would be a -1 for that. That would be a -2 for that. Well, that is good. These two are the same. These two are the same. This is the same. This is the same. But what about these two that I canceled out? I must include them as well. So that's also a +1 and a -3 over 2. Okay? And you can write plus or minus 1 if you want to save some space. All right, last one of these is this one. Let's give some more room, a little bit more. Okay, so the trick here, again, let's deal with this piece later, right? Because then we're going to need a common denominator. The trick is to do inside the parentheses. And the trick is to find a way to factor all these. First, no good. So I'm going to flip these over in order to multiply. But first, I notice I can maybe try to factor this by grouping. So that's factor out an A. We have a C minus D. Factor out a -B, and we also have a C minus D. Okay, we'll finish this in a second. Same at the bottom, A times C minus D. And now a positive B times C minus D. Times A to the third plus B to the third over A to the third minus B to the third. So I instead of dividing, I multiply by the reciprocal. And now I can continue factoring this to A minus B times C minus D over A plus B times C minus D times and these are going to cancel in a second. Let's wait till we get everything going though. This is the sum of a perfect cubes. These are the difference of two perfect cubes. So I'm going to factor both of these using SOAP. So this factors into a plus b times a squared, same sign, opposite sign, not a 2, always positive, over, same sign, opposite sign, always positive. Now we can start canceling, and then we can worry about adding into this thing. A minus b, a minus b, a plus b, a plus b, c minus d, c minus d. Now look, the only thing that's left is the same denominator. So basically we have ab over a squared plus ab plus b squared plus a squared minus ab plus b squared over the same thing, which is nice because that means that we can just add the numerator and the two numerators together. This and this are opposites. So we're left with a squared plus b squared over a squared plus ab plus b squared, which does not factor, it does not cancel, because there's not a 2 there. Okay? And we could go more in depth with all these different letters and what can and can't be equal to 0, but I think we're going to just leave that part out. Okay? So that was our simplification problems. Let's try some factoring and some solving some of the equations. All right, so when I look to factor this expression, one thing jumps out at me as being different than everything else. First, I would think of maybe trying to factor by grouping, but when I group it, it doesn't look the same. But if I rearrange this, now something jumps out at me, is that this is a perfect square trinomial. Okay? So I can factor it to x minus 6 squared. This is also a perfect square. It's 7y squared. And when we had the difference of two perfect squares, it factors into a plus b times a minus b. Okay, well if this is the a and that's the b, and I follow this pattern right here, this factors into a plus b, a minus b, and that is factored, okay? Using the technique of the difference of two perfect squares. With fractional exponents, we are going to factor out the smallest degree of each exponent. First, we're going to factor out the common factor number, and we're going to factor out the smallest exponent. That leaves me with a 1 there, plus 2, and when I factor something out, I want to subtract the exponent. So I'm going to take 1/4 minus a negative 3 over 4. 1/4 minus a negative 3 over 4 is 1. So I'm not going to put the 1 there. So we're pretty much done now. The only thing I want to do is clean this up by moving the negative exponent to a bottom of a fraction, and then realizing that I don't want to leave a fractional exponent in the denominator, I'm going to rationalize this by multiplying the top and the bottom by x to the 1/4 power, which has the effect of making this just x. The top would be 16x to the 1/4, 1 plus 2x. And now that is simplified and rationalized, just for fun. Let's solve some equations. Okay, so in order to solve this, I don't like those fractions. I'm going to multiply everything by the common denominator of the entire expression, which is x plus 1 times x minus 1. And I'm going to multiply just the numerators. Okay, so what happens is when I multiply this expression by this, the x minus 1's cancel, and I'm left with 8x times x plus 1 equals 4 times both of them, x plus 1, x minus 1, minus 8 times x minus 1. Okay, distribute 8x squared plus 8x equals, this is going to turn into x squared minus 1 when I multiply both of these two together. So we get 4x squared minus 4 minus 8x plus 8. Okay, let's get everything to the left because I see there's the squares are not going to cancel. So we have 4x squared. I'm going to subtract 4x squared from both sides plus 16x. That turns into a 4 minus 4 is equal to 0. Now, I do notice that all these things have a 4 in them. So I can divide both sides by 4 without losing any of the variables. So this turns into x squared plus 4x minus 1 is still equal to 0. What are the factors of 1 that subtract to 4? Well, there are no factors of 1 that subtract to 4. So I can't solve this by factoring. I have two choices. I could complete the square because there's a 1 in the front here, or I can use the quadratic formula. So x is going to be equal to negative b plus or minus the square root of b squared minus 4 times a times c. So 4 times 1 times negative 1 over 2 times 1. So we have negative 4 plus or minus the square root of 20 over 2. Now, I just got to be sure that that is simplified, which it's not, because I can split that into 4 times 5. So it turns into negative 4 plus or minus 2 radical 5 over 2. And so canceling out the 2's gives me negative 2 plus or minus the square root of 5. Okay. Absolute value. Isolate the absolute value first by subtracting 5 from both sides. This gives me the absolute value of x plus 1 is equal to negative 2. That's a problem. Absolute values cannot be equal to a negative number. This has no solution. If this was a positive 2, you would split this into 2 separate equations and solve them separately. But it's not. You got to recognize that that is a negative absolute, it's an absolute value equal to a negative number, which means this is undefined. Another quadratic. Set this equal to 0. And then nothing, no common factors here. So we have a couple choices. We could try to factor it, factors of 4, factors of 7, see if anything combines to give me 2. If you don't see it, you can jump right into the quadratic formula. So we have negative b, so that's negative negative 2 turns to positive 2, plus or minus b squared minus 4 times 7 times 4, which gives me a positive 112 over 2 times a. Okay, so this gives me 2 plus or minus the square root of 1/16 over 16. Okay. Now, let's think about whether or not the square root of 1/16 actually simplifies. And it does. 4 goes into 1/16. So we have 116 divided by 4 gives me 29. So we get 2 plus or minus 2 square root 29 over 16. I can't simplify the 16, but I can divide everything by 2. So therefore, x is going to be equal to 1 plus or minus the square root of 29. We divided everything by 2, so this is going to be over 8. Great. Let's just go through this real quick, even though we didn't get to this. Isolate the absolute value. So we have 3 minus x over 3 is less than or equal to 5. Now, because this is a less than, this becomes an and inequality, which means a conjunction, which just affects our answer a little bit. But the technique for these is to solve it with the positive case. And, 3 minus x over 3 with the negative case, but you reverse the sign of the inequality as well. Okay? So we subtract 3 from both sides. Negative x over 3 is less than or equal to positive 2. Multiply both sides by negative 3. Remembering that when you multiply an inequality by a negative, you also change the sense of the inequality as well. Same thing here. We have negative x over 3 is greater than or equal to negative 8. Multiplying both sides by a negative 3 gives me less than or equal to, because we're multiplying again by a negative, and 24. So that means that x is greater than or equal to negative 6, less than 24. It means x is in between those two things. So if I want to write this with a compound inequality, I would say that negative 6 is less than or equal to x, which is less than or equal to 24. If I want to write this with interval notation, I would say this goes from negative 6 to a positive 24 with brackets because it says or equal to. All right, let's finish with this one. When we look at this problem, it has 2 square roots. The way I approach a square root equation is to isolate one of the square roots first. So here's my first step. Is I'm going to isolate the square root by moving this entire expression to the other side. Great. Now I'm going to square both sides of this, which makes this square root go away. But this is now a binomial. And remember that when I square a binomial, I get a squared plus 2ab plus b squared. So these two terms can't have a radical because we have squares. This one can. Okay, so negative 1 squared is 1 plus 2 times negative 1 times this radical gives me negative 2 radical 3x minus 2 plus b squared 3x minus 2. Now, I want that by itself, so that way I can square both sides again. Subtract 3x from both sides. Oh, look at that. Nice. Goes away. 1 minus 2 gives me a negative 1 on this side. And let's just go like that. Add 1 to both sides. We have a negative 8 is equal to negative 2 times this radical. Now I could square both sides now, but it's easier to divide out the negative 2. Now, when I square both sides, I don't have to worry about any numbers. There's that one. So we get that 16 is equal to 3x minus 2. Add 2 to both sides. So x is equal to 6. You should, good habit, go back and plug in 6 and make sure this actually works. So plug a 6 in there. We get an 18 minus a 9. That's 9 squared as 3. Minus, plug in a 6 there. 18. Yes, 16 minus 4. 3 minus 4 is negative 1. Okay. And that was our review for Chapter P. Please feel free to get in touch with me if anybody has any questions. And I hope this answered all the questions on the type of problems you might see on your Chapter P test. Thank you.